Hello viewers, welcome to my channel IITJ Olympiads and AP Physics with Ambarish. First of all, wish you all a very happy Diwali. One of my subscribers had requested me to make a video on superposition theorem and the proof of the superposition theorem. So here it is. I am presenting the superposition theorem today. Okay. So what's the statement of the superposition theorem? In a circuit containing only batteries, say V1, V2 up to Vn, and resistors say R1, R2, R3 and up to Rm, the current through any resistor is of the form A1 V1 plus A2 V2 plus A3 V3 all the way up to An Vn. Okay, here V1, V2, V3 etc. are the EMFs of all the batteries. Okay, therefore we can find current through any resistor by considering one battery at a time. So it's a linear function of various EMFs. So for example, to calculate the first term, I can just put all these terms to 0, right? Similarly, to calculate the second term, I can put V1, V3 etc. all the way up to Vn equal to 0. Similarly, I can consider the role of one battery at a time to get this. Why we can do that? That is because there is no term of the form V1 into V2. That's the beauty of linearity. Okay, because of our system, if the solution is a linear combination of all the EMFs, then there is no term containing V1 into V2, so therefore we can consider the role of one battery at a time. Okay, that's what I've written. Therefore we can find the current through any resistor by considering one battery at a time and considering all other batteries are as short circuits, right? So for the proof, before I get into the proof, I'll just motivate the proof by an example so that you can easily understand my logic of the general proof. So let me just take a simple example. Okay, so let's say I have a simple circuit like this. There's a battery E1, another battery E2, then there are three resistors R1, R2 and R3, and there is current I1 here and there's current I2 here, and I have satisfied the junction law here, and there is the current I1 plus I2. So I have two unknowns and I have two loops. So there is this loop and there is this loop. So two unknowns and two loops, I can make the equation. So first equation, this loop I1 R1 and plus I1 plus I2 into R2 and then minus E1 equal to 0. Similarly for the second loop, I2 into R3, then I1 plus I2 into R2 and minus E2 is equal to 0. And now this is two variables and two equations we can easily solve, and if you solve you will get this is the result for I1. So what you are seeing for I1, there is some function of resistors and then there is multiplication by E1, and then again there is some function of resistances and then there is multiplication by E2. So what do you see? I1 is a linear combination of E1 and E2. There is no term like E1 into E2 or E1 square or E2 square, and therefore for calculating the first term I can put E2 equal to 0 and calculate the first term, and then for calculating the second term I can put E1 equal to 0 and calculate the second term, and then add the two terms to get the total current. Okay, and similarly for I2 also you can see that it is going to be a linear combination of E1 and E2. There is a pure resistor function and there is also pure resistance function. Okay, so we see that our solution is a linear combination of E1 and E2. There are no terms involving E1, E2 or E1 square or E2 square etc. We could as well consider them to be 0 one at a time and add the solutions to get the net current. Okay, so if you have understood this example, then it should be simple extension towards the general proof. So let's get into the general proof now. Let there be n current variables in a circuit after satisfying the junction law at all the junctions. So if you satisfy the junction law, you will be able to see that as many loops are there as there will be as many current variables for a general circuit, and then we can make the corresponding n equations for each loop. Okay, so what will be the form of equations? See, in any loop there will be some current and multiplied by some resistance, then some current multiplied by some resistance, and this will be equal to the EMF in the loop. So this is the form that equations are going to take. So there will be some coefficient of I1 which is a function of resistors, resistances. So let the equations be R11 I1 plus R12 I2 and so on. R1n In is equal to E1. Similarly, the second equation for the second loop equation may be R21 into I1 plus R22 into I2 and so on up to R2n into In equal to E2. Similarly, for nth loop it could be Rn1 into I1 plus Rn2 into I2 and so on up to Rnn into In is equal to En. Okay, Now suppose we have to solve this system of equations for I1. Suppose I am focusing on how to solve for the variable I1. Then what will I do? I will multiply all these equations by suitable constants and then add them up, so that the coefficient of I2 becomes 0 in the addition, and all the other coefficients become 0 when you add all the equations, and only I1 remains, and I1, and then there will be something, there will be some coefficient of I1, okay, and all other variables will be eliminated by if we multiply them with suitable constants, okay. So that's what I've written. Suppose we want to solve the system for I1, then we need to multiply all the equations by suitable constants, say Ci, and add all the equations such that coefficients of I2, I3, In all become 0 when adding all the equations. So let's look at this illustration, okay. So the same system of equations I have copied, and let's say these are the constants and I am multiplying them, and these are chosen such that I2 coefficient becomes 0 in the summation, I3, I4 and all of the way up to In becomes 0 except for the coefficient of I1. So then what will I get? So C1 into R11, C2 into R21 and so on up to Cn into Rn1. So C11 R11, C2 R21, Cn Rn1, whole thing multiplied by I1, and this will be equal to, on the RHS, C1E1 plus C2E2 and all the way up to Cn En. So what do I get for I1? It will be C1 divided by this whole thing into E1. Similarly, plus C2 divided by this whole thing into E2, plus so on up to Cn divided by this whole thing into En. So this is what we get, okay. And now you can clearly see that current I1 is a linear combination of all the EMFs. Once again, there are no product terms like E1, E2 or square terms, even E1 square, E2 square, 2 E1, E2, something like that is not there, okay. So thus we see that I1 is a linear function of battery EMFs. And what is this form? This is A1 times E1 plus A2 times E2 plus A3 times E3, where AI depend on the resistances alone. And this is what I wanted to prove. So I can put, for getting this term, I can put all these terms to 0, and for getting the second term, I can put this and other terms to 0 and so on, and add them up, okay. So now I am going to present to you a cute example. So here we have to find current I through the battery marked beta. So this is the battery marked beta and there is another battery marked alpha, and I want to find out the current through this battery, okay. So what do I do? According to the superposition method, we can consider one battery at a time and replace the other battery by a short circuit. So let us first forget the battery marked beta. Let us forget this battery and replace it with a short circuit, okay. You remove this battery and you connect it with a short circuit. So what does it look like? This is what your circuit looks like when you remove this battery. And now something beautiful has happened. See, this is a Wheatstone bridge, right? So because of this battery marked alpha, there is no current in the branch BD, okay. So some simplification has happened and the problem is now looking a little easier, okay. So first we forgot the battery marked beta and replaced it with a short circuit. We can clearly see that the circuit reduces to a Wheatstone bridge with nothing flowing from B to D, okay. So I due to alpha is 0, okay. Now let us forget the battery marked alpha. Now I'll forget the other battery. So I'll forget this battery and then I'll be having only the battery marked beta. So this I have replaced by this battery I have removed by a short circuit, and now I'm having a battery marked beta. Now you see in this there is a battery and resistor in series connected between B and D, and this resistor is connected between A and C. So I have just rearranged this equation, rearrange the circuit to look like the circuit shown on the right hand side. Can you see that the right hand side circuit is exactly same as the left hand side circuit, except because between B and D you see this is the resistor, and so between resistor and battery combination, so here also you see resistor and battery combination is there between B and D. So just it's a same topology, just a little bit of rearrangement, and then this resistor is connected between A and C, so I have directly connected between A and C. So these two circuits are, from the topology point of view, exactly same circuits, okay. And here again you can see this is another Wheatstone bridge. How beautiful is that? There is another Wheatstone bridge. You can see nothing is going to flow from A to C, and now you know that the current is only due to this battery. Now it's a simple circuit. You can as well forget this resistor And then what is the effective resistance of this? If you see, so this is R and this is R, so 2R in series, and this is R, 2R in series, and this 2R in parallel with this 2R becomes R. So this whole resistance becomes R, and this whole R is in series with this R. So therefore the current flowing through the battery will be simply E by 2R. Okay, and because of the other battery there was no current through this branch. Okay, so that's what I've written. So effective resistance across beta battery can easily be seen as 2R, and I beta is simply E by 2R. So total current becomes I due to alpha plus I due to beta, that is 0 plus E by 2R. So that is our final answer. Okay, so this was the application of superposition principle. Now there exist other superposition principles also with current sources and mixture of current and battery current sources and batteries, but for JE purpose they are not very important, although I am going to state them. One or two problems might help, you might get help by using those principles, like an Irudo problem is there with infinite mesh of resistors. So there the method of proof will be on the same lines that I have done for the superposition. So I'll just state the theorem. So a parallel superposition theorem exists with current sources in circuit. That is, if there are n number of current sources in any circuit, then current in any branch is linear function of the currents of various current sources. Okay, so capital I is B1 I1 plus B2 I2 and so on up to Bn In. Now and please remember in mind, constant current sources, they should be replaced by open circuits. Why? Because what does it mean to have a constant current source? That means, let's say I have a battery of 1 mole volts and then resistor of 1 mole ohms. So then that will supply a constant current of 1 ampere, right? Because a small resistor like 1 ohm, 2 ohm, 3 ohm is very small as compared to a 1 ohm resistor, 1 mole resistor, right? If I may use that term. Okay, so that's why, so current source is practically infinite EMF and infinite internal resistance. So there should be, current sources should be replaced by open circuits, unlike the batteries which are replaced by short circuits. Okay, and we can also have a superposition theorem for circuit involving resistors, batteries and current sources. Simultaneously batteries may be there and current sources may be there. There the current in any branch will also be a linear superposition of current sources and batteries. That is, capital I, if it is current in some branch, it will be of the form A1 E1 plus A2 E2 and so on up to AN EN plus B1 I1 plus B2 I2 plus BM all the way up to BM IM. So these are the currents for the different individual current sources. Okay, batteries to be replaced by short circuit and current sources to be replaced by open circuits. So that was my discussion on superposition theorem and its proof. I hope you enjoyed this discussion, and if you did enjoy this discussion, please do give a thumbs up to my video, and please share my video as much as possible in various WhatsApp groups, whatever study groups that you might be part of, or Telegram groups or Discord servers, or whatever other study groups you might be part of. So please recommend my video in various study groups, and if you have not already subscribed to my channel, please do subscribe to my channel. My channel is not monetized. It's the love that I receive from you in the form of subscriptions and comments and likes, and that's the money that for me, and that's what keeps me going. Thank you very much for watching this video, and do keep coming back to my channel for more awesome stuff.